All right, welcome to the first video of systems of equations. We are going to talk about in each video a different way of solving systems of equations. This particular one is going to be on graphing. So we're going to solve a system of linear equations using a graphing method. Okay, so first things first, let's talk about what a system of equations actually is. And that is two or more equations with two or more variables, and you're trying to find a solution that works for both variables. Okay, so here's kind of my introduction of it. Basically, what you're going to do is you're going to take an equation, graph it, and then take a second equation and graph it. The way that those two equations are graphed is going to be an indication of what the solution set is. Okay, so I'm going to first graph equation 1 here in orange. Notice that the equation is already in slope-intercept form, which is great for us. We just need a slope, which is 4/1, and a b, which is 3. So b is for beginning. It's where I begin my graph. And then we go 4/1, or we can go down 4/1, and I'm going to keep going here, down 4/1, down 4/1, and then I'm going to go ahead and, if I can, you know what, I'm going to try this. Oh, nice. Okay, and there's our line. Okay, now I'm going to go ahead and graph the next equation in green. But this one is not in slope-intercept form, so I'm going to put it there by subtracting x on both sides. So I'm going to have y is equal to negative x minus 2, which means m is going to be negative 1/1, and b is going to be negative 2. So again, b is for beginning, is where I begin my graph, and we go up 1/1. Up 1/1, up 1/1, and we can keep going. Or we can go down and to the right, down and to the right, down to the right, down to the right, and we can keep going. So here is my next equation of a line. Notice that they both, and what we call this intersect, meaning to say cross, at one particular point. This point right here, which is -1, -1. Okay, -1, -1, which means that this is the solution to the system of equations. And we can check to make sure that it actually is by plugging -1, 1 into both equations. So equation 1, if I plug in -1, 1, is going to be -1 is equal to 4 times -1 plus 3. -1 is equal to -4 plus 3. -1 is equal to -1. That works. Here's equation 2. So -1 plus -1 is equal to -2, which is indeed true. Therefore, -1, 1 is the solution to both systems of equations, because when we plug them in, it's going to give us true statements for both of them. Okay? So you want to find the intersection point of when we graph the two lines. Okay, so the first example that I had for here is when the two lines intersect at one point. So the number of solutions you're going to have is 1, and your solution is going to be a point, meaning to say an ordered pairs of x, y. Now, another situation that you could have is when your lines are parallel, okay? Meaning to say that they do not intersect. In this particular case, you're going to have 0 solutions, and your solution is going to be no solution. The last one is when the lines coincide, meaning to say you graph essentially one line on top of another. The number of solutions that you could have is an infinite amount. So what you would write here is all real numbers. You could say infinitely many solutions. You could say either of those things. Okay? So I am going to do a few more examples here. Okay, we have 3. And notice that none of these are in the right format. So we're going to have to get them to the right format. So I'm going to kind of give ourselves a little space here. And the first one, I'm just going to go ahead and start it for us. Negative y is equal to negative 2x plus 3. And then we're going to divide everything by a negative 1. So y is going to equal a positive 2x minus 3. So my m is going to equal to 2 over 1. My b is going to equal to negative 3. So I start at negative 3, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. Or we could go down to the left one, down to the left, down to the left. Okay, so there's my first line. And then I'm going to grab the second one and bring it down here. So I have x plus 3y is equal to 12. Subtract the x from both sides. Divide by 3. Negative 1/3 x plus 4. So my b is going to be 4. My m is going to equal negative 1/3. So I start at 4. And I go down 1 and to the right 3, down 1 and to the right 3, down 1 and to the right 3. And I can already tell that these are going to be intersecting lines at my point. 3, 3. Okay, so my solution is going to be 3, 3. And again, you can check your answer by plugging 3, 3 into both equations, and you should get the right answer. I always suggest plugging it into the original ones right up here. That's what I would always recommend, okay? But that is our solution. Let's try the next one, okay? So again, for both of these, I'm going to and I'll pick different colors so that we don't get confused. I'm going to go ahead and put them in the format that I need. So I'm going to add x to both sides. I have 3y is equal to x plus 6. Divide every term by 3. So y is equal to, now I can say 1/3 x. That's the same thing as saying x divided by 3 plus 2. So my m is 1/3. And my b is 2. So I start at 2. I can go up and to the right, up and to the right, up and to the right, or I could go down and to the left, down and to the left, down and to the left. And let's draw my line here. Okay, let's do the next one here. So I have the 3x minus 9y is equal to 9. So I'm going to subtract the 3x on both sides. Divide every single term by 9. Negative 9. And we're going to end up with y is equal to a positive 1/3 x minus 1. So my m is equal to 1/3. My b is equal to negative 1. So I'm at negative 1 and I go negative 1, up and over 3, up and over 3, up and over 3. Okay, and I can go down and to the left, down and to the left, down and to the left. Now notice something. I notice that these lines do not intersect. These are parallel lines. And I really shouldn't be all that surprised, because if I take a look over here, I see that my slopes are actually the same, which means to say there are no solution, or there is no solution to this particular system of equations, because I am never going to find a point that is going to intersect between these two linear equations. Okay, so now last one here. Again, we are going to have to do different colors, and I'll do this purple. So I'm going to grab my first equation and I'm going to solve for y. So I'm actually going to subtract the x and subtract 3y. So I have negative 3y is equal to negative x minus 15. And then I'm going to divide by negative 3 on both sides. And actually all three terms, that becomes a positive. So y is equal to positive 1/3 x plus 5. Where my slope is 1/3 and my b is 5. So I start here at 5, I go up and over 3, up and over 3, up and over 3, down and to the left, down and to the left, down and to the left. I'm going to graph my line. Okay. And so now I'm going to go ahead and change colors, and I'm going to do this one here. 2x minus 6y is equal to negative 30. So I'm going to subtract my 2y, or my 2x, sorry, it's 30. Divide every single term by negative 6. So that becomes y is equal to positive 1/3 x plus 5. Now notice, I have my same slope, which is 1/3, and I have the same y-intercept as my other equation. These are the same, which means to say this line is going to be literally on top of the other, because I'm starting at the same point, and all my slope points, all my steepness is going to be the same, which means to say I have infinitely many solutions. And that's going to be my answer for this particular problem. If you say all real numbers, that would also be a correct solution for this. So, recap. If the two lines intersect at one point, you have one solution, and that's the ordered pair, which in example 1 was 3, 3. In example 2, we had parallel lines, meaning you say we had the same slopes, which means they can never intersect, so there are no solutions. Last example, we had one line on top of the other, which means that these two lines are infinitely intersecting because they're literally right on top of one another. So there are infinitely many solutions. Okay? So I'm going to stop the video here. Make sure you practice, and I'll see you next video in substitution.